prove that 2n plus 1 into Pn x is equal to Pn plus 1 single prime of x minus Pn minus 1 single prime of x. So it is also another recurrence relation for Legendre polynomial. So now you want to prove left hand side is equal to right hand side. So by using the previous recurrence relation, now I want to take the help of first recurrence relation. So what is the first recurrence relation? 2n plus 1 into x into Pnx is equal to n plus 1 Pn minus 1x. So this is the first recurrence relation what we have proved in the last videos. I want to take the help of this relation. Now I am going to differentiate this equation. Differentiating this equation with respect to x. So what we get? Okay. So here 2n plus 1 is constant, x into Pnx. We are differentiating with respect to x. I am going to use a product formula. Keep x as it is. Derivative of second function. X with respect to x is 1. Second function as it is equal to n plus 1 is constant, Pn plus 1 single prime of x, n is constant, n minus 1 single prime of x. Okay, or you can simplify 2n plus 1 into x into P1 single prime of x, 2n plus 1 into Pn x is equal to n plus 1 Pn plus 1 single prime of x as it is, Pn minus 1 single prime of x. Now I want to find out the value of x into Pn single prime of x. From the recurrence relation 2 I can obtain this value. From recurrence relation 2, what we have proved, n into Pnx is equal to x into Pn single prime of x minus x. So I want to rearrange the terms. I want to obtain the value of this. So therefore x into Pn single prime of x is equal to n into plus Pn minus 1 x. Okay, now I am going to substitute this value in equation 1. I will call it as an equation 1. This value in 1. Okay, 2n plus 1, so it means within the bracket n into Pnx plus Pn minus 1 single prime x plus 2n plus 1 Pnx is equal to as it is n plus 1 Pn plus 1 single prime x plus n into Pn minus 1 single prime x. Multiply. Normal multiplication. 2n plus 1 into n into Pnx plus 2n plus 1 Pn minus 1 x as it is 2n plus 1 Pnx is equal to n plus 1 Pn plus 1 single prime of x plus P suffix n minus 1 single prime of x. Right? So now I want to rearrange the terms. Right? So for example, I want to consider 2n plus 1 n into Pnx. Now I want to search, is there any other word containing 2n plus 1 into n into Pn. I think from these two terms, what is the common thing? 2n plus 1, 2n plus 1. Pnx is common. Right? I will take out 2n plus 1, write down the remaining thing. Right? So from this term, 1, right, into Pn of x. Right? Okay. From these two terms. From this term and from this term. Right? And similarly, I am going to write down this term. Right? So this is equal to n plus 1 p n plus 1 single prime of x. Okay. Next, from this term Pn minus 1 single prime, Pn minus 1 single prime. So what we can obtain, P suffix n minus 1 single prime is common. I will write outside. Right? Within the bracket I will get n minus 2n plus 1 into the bracket right. I hope I have written all the terms, or this can be written as 2n plus 1 into n plus 1 Pnx. So this is equal to n plus 1 P suffix n plus 1 single prime of x. Right? So I have to simplify. N minus 2n means I will get minus n. So minus 1, or it can be written as minus times of n plus 1 p n minus 1 single prime of x. Right? So observe all the terms. In all the terms, so n minus 1 is common. Sorry, n plus 1, n plus 1, so n plus 1. Right? So throughout divided by n plus 1. So you can obtain 2n plus 1 Pnx is equal to Pn plus 1 single prime x minus Pn minus 1 single prime x. So I think this is the required equation, 2n plus 1 Pn. Alright, 2n plus 1 Pn, that is equal to Pn plus 1 single prime of x minus Pn minus 1 single prime of x. So thank you.